Okay, so basically after you have imported, you will see something like this for all those who have imported already. So like please write, you can't start the machines because of adapter 4 issues, so you'll have to go to please go to settings of each of these nodes. Let me repeat it. Please go to settings of each of these nodes, go to networks, and then go to adapter 4, and then select Intel instead of para virtualized network. Okay, and say okay. Similarly, please do the same for all the 3 nodes. Go to settings, networks, adapter 4, advanced, say okay, settings, networks, adapter 4. Okay, this is fine. Okay, so when you guys imported, I hope you have not given reinitialize Mac, right? You just blindly imported the OVA, right, into the virtual box. Okay, so don't reinitialize the Macs. And similarly, please go to your preferences. In your preferences, it will show you VirtualBox host only Ethernet adapter. You could see one Ethernet adapter in this. Mine is showing 2, but for you there will be one VirtualBox Ethernet adapter. Can you please go there? So how to go here? Let me repeat it. You will have to go to File, Preferences, Network, Host only networks. Just make sure that you click that, and there is an edit button on the right side. You can edit it, and you have to give 50.1 here. You'll have to give 50.192.168.50.1. You'll have to give IPv4 network mask as 255, 255, 255.0. And then so this is actually given in the slides too. You will have to so let me repeat it. We are doing the first step here. We are going to actually set the VBox IP address to 192.168.50.1. That's the step we are doing now. For that, the step is go here, go to File, Preferences, and then you will get this VirtualBox Preferences window. Go to Networks, select VirtualBox host and adapter, click Edit, and in that you do 192.168.50.1, and then you give IPv4 network mask. Go to DHCP server, give DHCP server IP address 192.168.50.100, 255.0. I mean, you can give a range, and then say OK. So let me actually show you the topology to get some idea on that. So your topology is going to look something like this. Okay, so you will have actually 3 types of networks, right? So you will have a 192.168.50 network, which is the lowermost in the line. You could see that 192.168.50.0/24 in the lowermost line. Okay, that is going to be your management network. Then you will have 192.168.254.0. That is going to be your data network, right? And then you have 192.168.56.0 on the top. That is going to be your public network. If you remember the slides we went through before the break, we told clearly a cloud will have multiple types of networks, right? We talked about management network, we talked about data network, and we talked about public network, right? Management network is used to control the elements in a cloud. Data network is used for elements themselves to pass data among themselves. Public network is used for the elements or the workloads in the cloud to access the internet, right? So I am just telling you what is my management network, what is my data network, and what is my public network. So I want you to configure the management network now. So in order to do that, first you have to actually go to so you have to go here, you have to select File, Preferences, again select Networks. In that, select host only network. If nothing is there, create a VirtualBox host only Ethernet adapter. If you already have one, you have to edit it to make it 50.1, 255.255.250, give a DHCP IP, and then say OK. Okay, and then I also told you to actually go to settings of each of this and make sure that the fourth adapter does not use para virtualize IO. Instead, you should change this to use Intel Pro network adapter and say okay. You have to do this for first two nodes. Yes. Uh-huh. Yes. Okay. Okay. 1 second. Yeah, so basically here, I should select this one. Okay. So basically whatever adapter you are choosing in the preferences and you are giving the IP, you have to select that here, because this is the one that will be using that IP. Okay. So similarly I should do the same. Thanks for educating me. I did not notice that it changed. So let me tell you why it changed. What will happen is, when you go to file preferences to host only networks, whichever is the first network there, that will be by default chosen when you import the appliances, and that's why it happened. Now we changed it to whatever is the one that we are supposed to use. Okay, so please do the same in your setups. If you have any problems in between, please let us know so that we can come and help in. After you are done, please start your workloads. I mean, like, let's first start the control node. 192.168.50.100. I mean, that's the server you can give, and you can give a range from 101 to 254 or something. I mean, basically that doesn't matter because we have actually configured static IPs in the appliances, so it'll already come. Like, that setting is actually not required, but just for completeness sake, you know, when you want to do it yourself and you want to take advantage of DHCP provided by VirtualBox, I'll recommend you to configure this. So each of these nodes are CentOS nodes, and the first node, as you could see, is ODL 31 control Mitaka. That's actually a combined control node that runs my OpenStack controller, that runs my ODL controller. Okay. The second node, which is ODL 32 compute Mitaka, is a compute only node. So it runs my OVS data path, which will be controlled by my OpenDaylight controller on the other node, and it also runs certain Nova hypervisor side services, which will enable Nova based VM spinoffs. So it has services installed on it that are OpenStack specific. Okay. If you are stuck somewhere, please feel free to call us. Yeah. Yes. Yeah, for the first two nodes you will need all of them actually. Like in the fourth one, I wanted you to select Intel in the advanced section. Actually, you can look at the slides here. Yeah, so you can look at the adapter 4 selected in the slide here. So I want you to have to change from para virtualized network to virtualized network here, and here you should select the virtual adapter that will be the communicating point from your laptop. Okay, so basically what I meant is 50.1 should be the IP that your laptop gets, so that you can SSH to these nodes via putty or somewhere else, because managing them through console is going to be difficult in VirtualBox. So better to use putty so that you can easily run the scripts and scroll down, scroll up, look through everything, right? So for that you need a VBox 0 IP. VBox 0 IP you should configure as 50.1, because in my OVS I have actually configured 50.31 and 50.32 as the management IPs for the first two nodes. Okay. So I just kickstarted one of the controllers. I got into the console. Actually, when you go and click inside the black box, there will be a dialog box that will open to say you want to capture keyboard, give capture. Okay, and check the box and say capture. From that point, if you want to get the mouse back, you have to press the right control. So here I don't have the mouse. I press the right control button. You could see the mouse appear. Got it? So I want to go back into the console. I click it in. Okay. So here username password, as I told earlier, is ODL and ODL. Okay. So let me see whether the IPs are available. So you can see ETH3 is configured statically with 192.168.50.31. So let's try to put into that. So for now, you need to just start only the first node. The remaining two nodes can remain powered off. Okay. What we are going to do is we are just going to bring up the OpenStack and the OpenDaylight controller that is available in the first node. Okay. This is clear? Any questions? Anywhere are you stuck? So when you open the SSH, it should show login as, which means it should be able to connect from your laptop. Okay. If you are stuck anywhere, please feel free to let me know so that I can come and help out. Okay, 1 second. For people who have been using VirtualBox in a routine basis, we will always have a virtual network adapter defined already. So for those who are using VBox first time, you have to create a virtual network adapter in file preferences. I mean, so just to educate, you have to go to file preferences, networks. Here, if you don't have any host only networks, you have to create one, because a host only network allows you to connect to the VirtualBox nodes from your parent host, right? So you have to create one here, and you can, after creating this plus, will create a network, and then you go and edit, and then you fill it with 50.1, 255, 255, 255.0. Okay. After you do that, you come to your laptop. So you should, please, you should see that 50.1 appearing here. Unless that happens, you can't actually connect your nodes from your host. Okay. Just make sure that works for you first. After that only you can go to the next step. how many of you are able to ping 192.168.50.31 from your laptop? Good, good. I mean, like, let's give a couple more minutes for others to train it out. For those who have actually done that, I mean, like, for those who are stuck, can you please take help from me or somebody? Okay, now how many of you are able to ping from your laptop the first node? How many of you? Like, I saw 3 hands raised earlier. Like, do we have more hands or? Okay. So, like, feel free to help each other. I mean, otherwise I'll also can come and help you. Just make sure of one thing. You have to have at least one virtual host adapter, and you have to configure that to have 192.168.50.1. And as soon as you do that and press OK, when you go to your laptop and execute IP config, you will see 50.1 appear there. And then you can actually start using any SSH utility to log into your node. Okay. So I have logged into my node. Can we like, do we have more than half the guys moved in along with me so that we can move further? So what we are going to do now is we are going to execute a script called stack.sh. That's going to do a couple of things. One is it will actually start the OpenStack controller. The second is it will also start the OpenDaylight controller. Both of them it will do. Actually, usually stack.sh does not start the OpenDaylight controller, but our script actually starts them both. So I have logged into the first machine. Okay. Hello. Can we proceed? Anywhere you are blocked? Anybody blocked it? I mean, like, excuse me? Strange. Guys, the first time you try to log in, there will be a couple of seconds for you to show the password. So don't do any control-C or anything at that point. Okay. After you have done first time logging in, the information will be stored by laptop. Subsequent logins will be pretty fast. So like, how many of you have heard about DevStack here? Anybody heard about DevStack? Great, yeah. I mean, good to see. I mean, all these people should have raised your hands when I asked about OpenStack. I did not see so many hands. DevStack is internal to OpenStack. So DevStack is actually used by developers in OpenStack to quickly bring up a OpenStack controller to try out their code pieces and then push for reviews from there. Okay. So what we have in this machine is actually a DevStack only. So we are going to stack up a DevStack. Okay. And then we are going to use that as the controller. So please go to OPT DevStack. So let me repeat it, like, we took the OVA, we imported the appliance. After we imported the appliance, we went and configured a VBox 0 host only network with 192.168.50.1. We went to each of the nodes and then we made the fourth adapter to use Intel, Intel NIC instead of the para virtualized IO. And then we started the first VM for now. We have not started the remaining two. And then we are now going into OPT dev stack to stack up the OpenStack controller. Okay. So you have to go to cd opt dev stack and then you have to run stack.sh. So I just started my stack.sh. I mean like that is an advanced section in the settings of that node. If you go to the adapter 4 and advanced section, there will be a para virtualize IO in the next selection. In that you have to select you just select one that is Intel. Don't select para virtualize IO and then press OK. More importantly, before you press OK, there make sure what is the virtual host adapter it's using. Whatever is the name there, that is your VBox 0. So that should be configured with 50.1 so that you can log in from any SSH utility. Okay. So this takes like 5 anywhere between 5 to 10 minutes. But since this is, go ahead. You can stop it. You can do a control C, do unstack.sh. And then you can, I would say like, you can again go and configure that and again start stack.sh. Okay, it fails for you. Okay. So go back to the slides. So this talks about the adapter change, and then like so I don't know whether you guys had a chance to go through your IF config on the started nodes. So on the ODL31 control, you will have the first ETH0 left for NATing. ETH1 is your data network, which is in 254.x network. ETH2 is again like internal, it will be used for public access later dynamically by SNATing. ETH3 is your management network, which is using VBox net 0, enabling you to actually access your node from the laptop. Okay. Same applies to ODL32 compute. Most of it applies to router node as well. So make sure, like even though this is offline, please make sure you are connected to the internet. There is a wireless connection available here. So please make sure and then run stack.sh. Make sure you are able to complete stack.sh successfully. I'm sorry. So one clarification is, stack.sh, if you run it once, right, it is an ephemeral content. If you shut down your machine and if you restart, you have to rerun stack.sh to bring the services. Okay. Whereas in a production, it will all be installed services. So if you restart, the services will automatically restart. But since this is dev stack, if you bring the machine down and you bring it back up, you have to rerun stack.sh. Okay. There is no state saving with developer stacking actually. Like ideally developer stacking is used for dynamically bringing up a set of services with top of the trunk code pieces. Here we have actually pinned it to a certain version on the OpenStack branch, and we have tuned offline to be true, and so we are using that setting so that you can quickly bring it up. Usually stack.sh brings up 6 to 8 services. Unless all of them comes up fine, you cannot actually get a working cloud. Yeah, it's the settings are all right. It should come up. Yours is a Windows 7 platform or Windows 10? Okay, so that's what we actually tried our trials with Windows 7 as the platform. That's what we have. So yeah, yes. Yeah, so basically this is where companies are innovating, right? This comes under DevOps. So HP uses Ansible driven deployment of OpenStack. Red Hat uses Chef and Puppet based deployment of OpenStack. And then VMware uses some other technique to install OpenStack services. So it's a DevOps business. So that's what this is called as a there is something called as IaaS life cycling. So what that indicates is how do you bring up a cloud, and how do you manage to say there are multiple levels in a cloud, right? You can upgrade a VM for a tenant, or you can upgrade a hypervisor that is bought by a tenant, or you can upgrade all the services in the cloud, right? So upgrading the services in the cloud are all driven by a IaaS life cycle. So what each company does is it actually comes up with an IaaS life cycle product. For example, if you take Mirantis, Fuel is their IaaS life cycle product. If you take HPE, Helion is their IaaS life cycle product. For Red Hat, it will be RHOS or something. So like that, each of them have their own technology to bring up a cloud, and that's what is a production grade OpenStack cloud. Okay, we are not now doing a production grade OpenStack cloud. We are doing a developer based OpenStack cloud. Okay, which is ephemeral, which means if you reboot the machines, the cloud goes down. That's it. Okay. So let me repeat what is ephemeral. Ephemeral means short-lived. So what is short-lived is like, something that is not persistent, pretty simply put it, right? So if you do a stack.sh and after that if you power cycle the machine, that's it. I mean, like, you have to restack all the services. That's what I meant actually. That is all possible. If a VM is suspended, you can resume the VM again, provided your stack is up. That's all fine. You are asking about Horizon access, sir? Excellent. Admin, I guess. Huh? Yeah. So basically, okay, after you run stack.sh, the last 5 lines will give certain piece of information. In that, it will actually tell you how to access Horizon. With that, you can actually access Horizon. So when you want to access Horizon, you should actually use 50.31 as the IP, not 254.31. Okay, so let me show you how stack.sh for how many of you stack.sh completed? Okay, did you get success message there? Actually, like, how to say that, you will say the default yeah, okay, na came up fine. Okay, actually for me it's not coming up. So so basically for those whom it has came up fine, please go and start the next. There is the second node and the third node in your virtual box. Please start one by one each of them. The password and username remains the same for both of them. So what you did all along is to bring the OpenStack controller and ODL controller up. Okay, now you are bringing the compute node up. Okay, so the second node is the compute node. Please bring it up. Third node is your router node to enable access to internet. Please bring that up too. Okay. For the second node, needless to say, again you have to set the adapter 4 correctly, the settings. Third node does not use adapter 4, so please don't worry about that. Yeah, you have to do a ps minus af grep OpenDaylight. It should show you the process, Java process running. Usually if your stack.sh completes, you can, it usually starts to run. Can we proceed further? Can you proceed further? Yes. Nothing. It's actually basically, you know, like it connects from the, it connects from our 54 network to whatever is the NAT IP. So there is a NAT which is 10.2.x, right? So what we want is, we want to access external network, right? So to take from our public network of 192.168.54 to whatever is the NATable IP in this locality, that's what that router is supposed to do. So you know, like for all those who have completed stack.sh, please see the slides. I mean, like, I'm sorry. So you can go to OPT tools, please. cd/opt/tools, please. Okay. So you could actually do an ls there if you have time. I mean, like, you could see that it has a couple of scripts already. Okay. You can see it has I mean, I mean, like, there are many scripts in OPT tools. You could see all of them start with OS underscore, right? OS underscore add nano, OS underscore add admin key, OS underscore add net 0, OS underscore add VM 0, OS underscore add net 1, add VM 1. So what all these do, right? They just, each script is written so that it's easy for you to, you don't need to remember the OpenStack command, which is pretty large to type. So we have given you scripts where you can just execute the script right there to proceed further. Okay. So for example, add nano adds a nano VM flavor to Nova. So any of you know about Nova flavors here in this room? Okay, great. So you know, usually Nova comes with 4 flavors: small, medium, large, and huge, right? So, you know, we may not have that much RAM and HD capacity in our laptop. So we have created a new flavor called Nano. So add Nano will do that. And then, like, add admin key again allows you to access the VMs booted by you without passwords. Okay. And then, like, add net 0 creates a neutron network. This is what I actually mentioned as virtual network at the previous session, right? In the morning session, I talked about tenant creatable virtual networks, which will be realized on the physical networks, right? So if you want to create a virtual network in Neutron, you will have to run this script called add net 0, which will create a Neutron network. Add VM 0 will boot 2 VMs on that Neutron network. Okay, it will boot those VMs on 2 different compute hypervisors. You could see that the first VM is booted on ODL 31 node, second VM is booted on ODL 32 node. Okay. Then after adding the first net 0, after adding VMs on net 0, we'll go again and add new network net 1, and then we will add VMs to net 1. Okay, and after that we'll add a router and add both those networks to the router, and at that point we can actually try intra subnet, inter subnet use cases. After that gap, we will actually add an external gateway for this router which we created. And then through that we should be able to access the internet. Okay, so this is the goal actually. This actually you know, like, this does not educate you on advanced services in Neutron. For example, we are not touching on firewall as a service, we are not touching on L2 gateway, we are not touching on load balancing, we are not touching on you know, like QoS and all. But you know, the procedure you follow here will apply to almost all the services. I mean, like, only for you the APIs will change. You will create new scripts that will create a firewall, that will add a rule to the firewall. You will create a new load balancer and you will add a member to the load balancer, right? You will create a load balancer pool. To that pool you can add members. Similarly, for L2 gateway, you will create an L2 gateway, you will attach certain switch ports to the L2 gateway, and then you will bind a virtual network to those switch ports, right? So your API will change, but overall idea of this workshop is you get your hands wet with OpenStack REST CLIs as well as OpenDaylight CLIs. Okay. So fortunately, the stack.sh came up for me after a while. I have not tried that in this mission. You can try that, but actually, like, I haven't tried that myself. Excuse me? Yeah, but I could see that the controller is running for me actually. So that is sufficient enough for us to go and start executing OpenStack CLIs. Okay. So before we go further, have you guys heard about local.conf? Most of you should have heard about it by now. But just to mention, local.conf is the set of settings that you'll have to give to DevStack to tell what services it has to start when you want to start an OpenStack controller. Okay, so you could see that in OPT DevStack in your machines, there will be a local.conf in each of those two nodes, right? Not the router node, the ODL31 node and ODL30 node. You will see a local.conf. So those settings are some things that you can use offline also to bring up your OpenStack controller. Okay. Excuse me? Okay, actually for that you have to place your image in a location that is accessible from the OpenStack controller, and then you have to use a command called glance image create. So you have to give the physical path of the location of the image, and then you do glance image create. What it does is glance. So by the way, glance is actually image service facility in OpenStack. I told you, like, there are about 100 odd services running in an OpenStack domain. Glance is an imaging service. Responsibility of an imaging service is to give you an ability to manage tenant and cloud images in a cloud, right? Tenant and cloud admin driven images in a cloud. And glance image create will take the real image from the location, and it will copy it in a location which is accessible easily for you to spin off VMs based on that image. And when you yes. So in this particular node I have given you, I already have Cirrus image available in OPT glance folder, and so glance image create will be executed as part of a stack.sh, and so you don't need to do anything extra. You can directly start using the using that image ID given by glance to fire the VMs. So you can think like, how come? So when you run stack.sh, for you the image ID created will be different. For me it will be different. For everybody else it will be different. But still the scripts will work, because the scripts automatically grep for a particular image name and then take the ID and then use them in the script. So when you look through the scripts, you will understand how it works actually. That's why the scripts will work universally for us, even though ID is generated for your stack and for his stack and my stack would be obviously different. So please execute stack.sh on the second node also now. I hope you will be by now knowing how to do that, right? I mean, you have to again log in and then go to OPT DevStack there. The second node is 50.32. Okay, login ODL is the username password, and then you can go to OPT DevStack, and then you have to do stack.sh there. In the meantime, you can also start the router node, power it on just. Anybody? Yeah. Yes. Yeah, so basically this image already has the bundles. So in ODL there is something called as a properties file, actually system.properties file, for those who are unaware. in system.properties there is a parameter called features boot. So in features boot you can tell when I bring up an OpenDaylight controller what are the bundles it has to install and bring up. So in that actually we have given something called ODL-network-OpenStack. So let me repeat that. It's a good question. You should have embedded that into this. So it is ODL-network-OpenStack. This is the bundle. This is actually the feature. So you will have to do, if you have not given ODL network-OpenStack in your features boot list, you have to bring up the Karaf container and then you have to type feature install space ODL-network-OpenStack. So what that will bring is, that will bring up your Genius bundles, that will bring up the network related bundles, which means it will bring up my L2 service, L3 service, DHCP service, what all I talked about in the previous session in the diagram, right? Within the network box, all of them will actually come up. Okay. No. In this, as I said, we have ingrained this ODL network OpenStack in the features boot. So automatically as part of stack.sh, it will come up. So when you do a ps-f grep OpenDaylight, you will see a Java process running. Just make sure that is running. Yeah, if you give feature install, all the dependent packages for bringing that feature will be invoked and they will be brought up. So ODL network OpenStack is only to do network virtualization with OpenDaylight. So if you want to bring BGP as a service in, so ODL has many services, by the way, similar to OpenStack, ODL has many services. If you want to bring in BGP as a service, you have to actually bring up something called ODL-BGP-PSUP. So that will bring you BGP as a service. Similarly, like people who have written services and put in ODL, they'll have their own feature names. So if you do feature list, it will show you what all features are available in ODL. In that you can choose one and say feature and install that feature, and that will come. Right? It has to be in your distribution. That's all. Usually, since we have taken the whole ODL distribution, all features are available in this distribution, but we are using only ODL network now. Okay, we have installed by default only ODL network OpenStack. So please start your router node, and again ODL is the username password. Please give that. No need to do anything on this node. So like, have you made sure your second stack.sh completed? Please. Right. Okay. I want you guys to try, get your hands wet. Go to the first node, go to opt dev stack, use source openrc admin. You know why this has to be done, right? Why should we do this? What is it? No. Why should we do source openrc admin? Partially right. Again, partially right. Okay. So basically, why we need to do this is, when you want to execute anything in a cloud, you have to set a user context. Okay. So the user can be a cloud admin or a tenant. So by using source openrc admin, what I'm telling is, I am a user with the name admin and I belong to admin tenant. Okay. So anything that you operate in a cloud, you have to be either an admin or a user. So you have to set a context. So we are setting the context. In addition to setting context, some extra environment variables are also set, right? That's all it is. So you can actually do env. So you could see these are the OpenStack parameters that are set by source. One second. Okay, so you can see the OpenStack specific settings here, right? So in OpenStack, the highest grade is not a grade, like basically OpenStack looks at divides a cloud an IaaS into something called regions first. Okay, and within a region you have something called a domain. Okay, and within a domain you will have something called a zone, and within a zone you will have something called hypervisors. Got it, right? There is no diagram to explain, but let me repeat it. You have a region, you have a domain, you have zone, and you have hypervisors, and within hypervisors you will have workloads. Okay, so here my name is region 1. My no, I am an admin tenant. The project name here refers to the refers to actually the the domain. I am admin domain actually. Like my tenant name is admin. I am an admin user. Okay, and auth URL indicates what is the what is the identity URL. You know the use of identity. Anybody knows the use of identity here? Okay, if I want to talk to a secure person, right, I'll have to exchange a token with that person for security reasons. In order to generate the token, I'll have a service that provides me tokens. So Keystone is the service in OpenStack that is responsible for generating tokens. Any other service you need to talk to OpenStack, you have to first get a token from Keystone. Keystone establishes whether you are a genuine user. Based on that, it will generate a random token and give you the token. Okay, and it is that token you will use to establish a REST API communication with all other services in OpenStack. Okay, so that is why Keystone is also called as an identity service in OpenStack. Okay, so now you have done source, OpenRC, admin, everybody. Can we do Nova hypervisor list, please? Quickly go ahead, like we have only 20 minutes looks like. So Nova hypervisor list should show you both as enabled. Is it showing for you? Okay, then quickly go to OPT tools. Okay, and then execute one second. So there is command 1 of 4, 2 of 4, 3 of 4. First execute add nano /os_add nano. Can you execute add nano? So what does add nano do? It creates a Nova flavor of nano type. Okay, so you can see that it created m1.nano. Then you do os.add admin key. Okay, so we don't have any network, right? So by the way, Neutron netlist shows you what virtual networks are there. We don't have any networks yet. So what we'll do, we'll actually create a network. Okay, for it you have to use os add net 0. Please execute os add net 0. After that, first is add nano, then you have to do os add admin key. Okay, and then is the slide visible for people in the back? Visible, right? Okay, os add nano followed by os add admin key, and then after that you execute add net 0. So while you execute it, let me educate what it is. Add net 0 creates a new Neutron network, okay, by the name vxnet 0. You can see it here. It creates a new network and a new subnet by the name vxnet 0. So you have created a network and a subnet. Okay, after that we will add certain VMs. Actually, like Nova list will show you what VMs are there. We have not had any workloads yet, so we'll add 2 VMs on this network. So we have to execute add VM 0. So we just fired the first VM. actually these are the URLs for the VMs. So you can copy paste them. Oh, sorry. You can actually access the console of the VMs by taking the URL. There is a URL printed, right? Nova get VNC console prints you a URL. After executing add VMs, you will get two URLs, one for each VM. You can copy it and then you can open that in your browser. Just make sure you change the IP to 50.31. Don't use 254.31. Okay, and then press enter. You will get some console. Okay, are you getting the console at least? After that, you log in. That it's a Cirrus image. Who have used OpenStack would be very aware of this. Give Cirrus kubewin and then you will log in. You will see that the VM got IP 10.100.5.3. Okay. So before we go there, I want to educate you certain things. Have you heard about sudo ovs vsctl, sudo ovs ofctl commands? Have you ever? So these are the commands. These are just the utility commands that enable you to actually manage an open vSwitch. So now I've executed sudo ovs vsctl. So in this you can actually see that we have actually two tab ports, right? So one tab port represents the DHCP VM, which gives IP addresses for the workload we spinned off. The second tab port is one of the VM itself. Okay. Similarly, if you do a sudo ovs vsctl show on ODL32, you will again see that it has one tab port which represents the second VM. So you have VM VX0 and VM VX1. VM VX1 is on ODL32 and VM VX0 is on ODL31. So by doing a Nova show, you will know where these VMs are residing. So you can do a Nova list and then a Nova show. We will do VM VX02 Nova show. That will tell you which hypervisor this VM is resident. So you can see that it is available in hypervisor ODL32, right? So the next step we will do is actually we fired this VM. We know that actually we have two VMs now. One is available with IP 10.100.5.3. Another is available with 10.100.5.4, right? So let's try to see if the other guy pings from here. So you can see that intra-subnet communication is working fine, which means, one VM is able to talk to other VM by through switching, basic switching, right? Because I'm pinging from 5.3 to 5.4. Okay. Yeah. So when you executed the add VM0 command, Thomas, you will get one URL. If you have missed the URL, you can re-execute the same command. So the command here is here. The command is here. Nova get VNC console VM name no VNC. You'll get a URL. You paste that URL by changing the IP from 254.31. Just make it 50.31. That's your management IP. Okay. And then you press enter. You will get to a console. Give Cirrus kubewin and then you will log into the VM. Okay. And then from there you can do intra-subnet ping from 5.3 to 5.4. Next step for us is to actually do we will create the second network and the second we'll create the second network and two more VMs on the second network. Okay, because for routing, for you to get hands wet with routing, you will need two networks, right? So we'll actually create a second network and second. So again, go to your ODL31 control node and then execute in OPT tools do add net 1. Okay, execute OS add net 1. That will create the second network actually. So we have two networks. One is 10.100.5.0. The second network is 10.100.6.0. Okay. After executing that, please fire the VMs using OS add VMs 1. Okay. You can execute add VMs 1. This will fire two VMs on the 6.0 network. So if you are blocked somewhere, please raise your voices. So Hanuman just indicated me for some of them you are not able to log into VM console. Please use only IE browser. With Chrome, the console is not working. Some bug is there actually in the image which makes console inaccessible with Chrome. Please use IE or Firefox if you have it. IE you must be having it if you are a Windows user. If you are a Ubuntu user, you must be having Firefox. Is it? For those who are not able to access the VM console, you can at least do switching by logging into the DHCP namespace and pinging from there, or like use a browser like IE, with which this was demonstrated. With IE it works. So I now created the second network and second VMs. You might have looked at. Huh? You have to give 50.31 as the IP, not 254. Okay. So for others who want to try it out, sudo IP netns list will show you the DHCP namespaces, guys, please. Okay, so you can try it this way. Those who are not able to log into VM console can try it this way. You can actually go to the DHCP namespace and ping from there. Okay, so how to do that I just showed. You can do sudo IP netns list. It will give you two different DHCP namespaces, one for 6 network and one for 5 network. Okay, so how do you know which one is which? You have to do netns ifconfig. So you can do sudo IP netns exec so this will show you that this belongs to 6 network. So from here you can actually ping all the VMs in 6 network. So sudo IP netns exec DHCP namespace followed by ifconfig will tell you this DHCP namespace is tied to which network. From there you can ping the respective VMs. Okay, so we have fired 2 VMs. Now we will go and create a router. We'll go to L3. You guys have got L2 working, right? Okay, so we'll go to L3. L3 is about adding a router. Let's add a router by doing os add router.sh. You could see that from the VM you cannot ping the other guy, right? I mean 10.6.3 is not pingable from 5 because there is no routing entity, right? So we'll create a neutron router and add 6 and 5 networks to the router. So for that, please go again to tools and execute OS add rtr.sh, please. Have you done that? You guys are able to do that, please? Okay, so you could see that two commands came, like added so the router name is extrtr. So you can see by neutron router port list. You can see what are the interfaces on the router. You can see, like, 10.100.6.1 and 10.100.5.1 are the gateway IP addresses on this router for those two networks. Okay. Now we will go again here and we will try if inter subnetworks. As you could see, I am able to ping 6.3 from 5.3. Okay, we have enabled routing, and so packets are getting routed. Okay, so you can ask, usually how this is enabled, right? So the way to see that is, you can do a control R and then do dump flows. Okay, and then you can do pipe to grep table ID equal to 21. Can you guys please try that out? I mean, so you could actually see that the 4 VMs we spinned off will appear in table 21. Table 21 is the routing table, by the way, in OpenFlow. Okay, in the OpenFlow pipeline, table 21 is also called as the FIP table. It's also, I would say it's a de facto routing table actually. So you could see that 4 VMs have appeared in the routing table: 5.3, 5.4, 6.2, 6.4, and 6.3, and 5.2. So in this 5.2 and 6.2 are DHCP VMs for the respective networks. 5.3 is the first VM, 5.4 is the second VM on the first network, 6.3 is the first VM, and 6.4 is the second VM on the second network. Okay. So in table 21, flows will appear only if you are actually enabling routing across networks. Okay, if you are only going to do switching, the entries will appear only in table 50. Okay, and table 50 is you might have seen a network, you might have seen this diagram that was shown by Vishal in the before the break session, right? Did you guys notice different colors in this? The boxes are in different colors, right? What it indicates is all boxes of the same color belong to the same service. Okay, so if you see here, the brown color boxes all belong to L3 service. So you can see L3 fib in the center. This is 21. This is my routing table. Okay. Similarly, you could actually see the ocean blue table. That is your actually switching related tables, which is ELAN. So you can see 50, 51 on. Okay. So tables from 50 to 55 are used for switching. Tables from 20 to 29 are used for routing. Let me clarify. Tables from 50 to 55 are used for switching. Tables from 20 to 29 are used for routing. Okay. Yeah, tables from 50 to 55 are used for switching. Tables from 20 to 29 are used for routing and NATing, by the way. Okay, NAT is also a routable. NAT executes along with a router, because NATing is a feature in a router, right? And so 20 to 29 are the tables that are responsible for routing overall and NATing. 50 to 55 are useful for switching. Okay. So now, we are able to ping across subnets. We are able to ping on the same subnet, which means we just managed to complete 2 use cases, right? At least in this hands-on workshop, you have completed the first 2 here, right? You are able to ping within the same subnet. You are able to ping across subnets. Now we will try to see if you are able to actually access the internet, right? For that, what you have to do, you have to actually put a public IP interface into the router, right? So that the same router can actually enable you access to the public network, right? So let's try that. we will actually, there are a couple more script you have to execute actually. So you can see that there is a script called add ext network. First you have to create an external network. We are going to use a flat type of external networks. Okay, so please go to your control node and execute os underscore add ext net dot sh. Have you done that? Please try that. After that, please do os underscore add floating IPs dot sh. So you can see the line that says set gateway for router. Have you seen this appearing for you? That indicates that our ext router now got a new port on the public network. So this you can ascertain by using Neutron router port list ext router, which is your router name. You could now see there is actually, like, you know, there is one more entry coming here called 192.168.56.9. If you see our earlier slides, let me go to our earlier slides. I clearly showed in the topology that you know, in our topology I told earlier only that we have actually 3 networks. In that, our public network is on the 56 gap, right? So you could see that we now set a gateway for our router on this network. That will now enable VMs on the internal private networks to be able to access the internet, which is accessible via the 56 network. So your VMs are on which network? 100.5 and 100.6. So internet is on which network? It is on 192.168.56.x. So now we have taken a gateway port and we have attached it to the router. Through that router we are going to access the internet. So you know, please execute os add floating IPs too. So this script creates, people are aware of what floating IP is, guys? You know, what is the advantage of floating IPs? Anybody know what is the advantage of floating IPs? Okay, good. So floating IPs enable accessibility of workloads in a cloud from an external network. So it can be a public network, you know, that is given by your provider, or it can be an external network within your organization that again has another hop to go to the real provider. Okay, so to enable access directly to a VM from an external network, you are allowed to use for floating IP. So all websites today have floating IPs, are using floating IPs. Usually what happens is we will not, OpenStack allows you to associate one floating IP per fixed port actually. So usually what happens is, like, a vendor purchases a pool of floating IPs and then he distributes those floating IPs dynamically across a whole bunch of instances. So when he wants to bring one of the instances down, he will disassociate the floating IP from that instance, associate it to the other instance. Okay, this will not be manually done. This will be auto driven by their own scripts. So when they want to bring some, say for Amazon says runs 50 instances, he will have only 10 floating IPs actually. Those 10 will actually dynamically associate it to one of those 10 of those 50 and things will be running. When they want to bring some instances down, they bring it down automatically. These floating IPs will get disassociated and reassociated to other live instances. So your traffic to the web server will continue from a user point of view. So that's how they actually manage floating IP to fixed IP mapping. Okay, here we did it manually. We are creating a floating IP here and we are associating the floating IP manually using the REST API. But in production, all these are triggered by orchestration scripts. And go back to the VM. So you can try to ping www.google.com from your workloads. You could see that google.com responds to your pings from an IP 172.217. Have you guys tried this already? Okay. Okay, so this actually I mean, with this I think we tried even the internet access use case. So you know, like, just some ending note, like, like any questions you have on L2 service, L3 service, L2 gateway service, firewall service, QoS, all these are now bundled as part of network. So if you have any questions, you can always port to network-dev mailing alias, okay, and we will be glad to respond. And I would like to take this opportunity to thank my colleagues like Hanumant, Kiran and Abhinav for helping this workshop happen. I don't think without them it will be possible. So I would definitely like to thank them this juncture. And they will be presenting the L3 forwarding as a service in the afternoon. Please make sure you attend that to get a deep dive on how L3 works in OpenDaylight. L3 is so central that it's going to be used by other services, and so a deep dive would definitely help you to eventually become a contributor to OpenDaylight as well. Okay, and then apart from that, like if you have any general questions, I'm opening for Q&A for the next 5 to 10 minutes. Please go ahead. Yes. 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 Okay. So basically, if you want to use the DHCP service provided by network, there is a configuration available in ODL REST API under DHCP service -config. There is a configuration there that says controller enabled : false. The default is false. So in that you have to go and change that using a REST API. You can paste a REST API there. Actually, you have to execute a REST API to make controller enabled as true. When you do that, actually the ODL controller will act as a DHCP server. Yeah, you don't need to actually fire the QDHCP. You have to disable the DHCP service from your local.conf. Yeah. So basically that's a choice you make, whether you want to use an external DHCP server or you want to use an OpenDaylight DHCP server. If you want to use OpenDaylight DHCP, disable that service in OpenStack local.conf and then make control enabled to true within the DHCP service config of your OpenDaylight controller. That's it. Basically when you go to customer deployments, right, carrier grade deployments would want to use vendor driven DHCP services. So they will actually use controller DHCP false and use the vendor given DHCP servers. But the enterprise grade and below enterprise grade, like small to medium businesses, they may not have the cost in their pocket to actually go and buy another external DHCP service, right? For them, actually, they can either take advantage of the stock Neutron DHCP server, or they can actually use the ODL DHCP server. Both of them give you high availability, so there is not much of a difference from both of them. I mean, if you use the stock DHCP service, actually you will burden your OpenStack controller cluster. If you use the OpenDaylight DHCP service, you will burden the OpenStack cluster, OpenDaylight cluster. That's all it is. And networking services are not paid by the vendors, by the way. I mean, if you are saying you are giving this many networking services, they are not going to pay you extra for that. Basically, what typically a company makes money is on how many servers you sell. And so obviously, if your infra is going to use more servers, you are going to lose the money. So ideally, what you will do is you will run all your networking services within your cluster, and that cluster can be an OpenStack cluster or a OpenDaylight cluster. So I hope you enjoyed the hands-on. So if you have any questions, you can reach us in the network dev mailing list, and then I am also available in IRC for people who are using IRC. I am available with the name Vivekanandan Narasimhan, so you can use that tag to touch base with me on IRC. Any questions, you can feel free to connect to us in unconferencing sessions. Thank you guys. Thank you so much. for people who have been using VirtualBox in routine basis, we will always have a virtual network adapter defined already. So for those who are using VBox first time, you have to create a virtual network adapter in file preferences. I mean, so just to educate, you have to go to file preferences, networks. Here, if you don't have any host only networks, you have to create one, because a host only network allows you to connect to the VirtualBox nodes from your parent host, right? So you have to create one here, and you can, after creating this plus, will create a network, and then you go and edit, and then you fill it with 50.1, 255, 255, 255.0. Okay. After you do that, you come to your laptop. So you should, please, you should see that 50.1 appearing here. Unless that happens, you can't actually connect your nodes from your host. Okay. Just make sure that works for you first. After that only you can go to the next step. How many of you are able to ping 192.168.50.31 from your laptop? Good, good. I mean, like, let's give a couple more minutes for others to train it out. For those who have actually done that, I mean, like, for those who are stuck, can you please take help from me or somebody? Okay. So basically, after you have imported, you will see something like this. For all those who have imported already. So like, please write. You can't start the machines because of adapter 4 issues. So you'll have to go to, please go to settings of each of these nodes. Let me repeat it. Please go to settings of each of these nodes. Go to networks, and then go to adapter 4, and then select Intel instead of para virtualized network. Okay, and say OK. Similarly, please do the same for all the 3 nodes. Go to settings, networks, adapter 4, advanced. Say OK. Settings, networks, adapter 4. Okay, this is fine. Okay. So when you guys imported, I hope you have not given reinitialize Mac, right? You just blindly imported the OVA, right, into the VirtualBox. Okay. So don't reinitialize the Macs. And similarly, please go to your preferences. In your preferences, it will show you VirtualBox host only Ethernet adapter. You could see one Ethernet adapter in this. Mine is showing 2, but for you there will be one VirtualBox Ethernet adapter. Can you please go there? So how to go here? Let me repeat it. You will have to go to File, Preferences, Network, Host only networks. Just make sure that you click that, and there is an edit button on the right side. You can edit it, and you have to give 50.1 here. You'll have to give 50.192.168.50.1. You'll have to go IPv4 network mask as 255, 255, 255.0. And then, so this is actually given in the slides too. You will have to. So let me repeat it. We are doing the first step here. We are going to actually set the VBox IP address to 192.168.50.1. That's the step we are doing now. For that, the step is go here, go to File Preferences, and then you will get this VirtualBox Preferences window. Go to Networks, select VirtualBox host and adapter, click edit, and in that you do 192.168.51, and then you give IPv4 network mask. Go to DHCP server, give DHCP server IP address like 192.168.50.100, 255.0. I mean, you can give a range, and then say OK. So let me actually show you the topology to get some idea on that. Back, you have to press the right control. So here I don't have the mouse. I press the right control button. You could see the mouse appear. Got it? So I want to go back into the console. I click it in. Okay. So here username password, as I told earlier, is ODL and ODL. Okay. So let me see whether the IPs are available. So you can see ETH3 is configured statically with 192.168.50.31. So let's try to put into that. So for now, you need to just start only the first node. The remaining two nodes can remain powered off. Okay. What we are going to do is we are just going to bring up the OpenStack and the OpenDaylight controller that is available in the first node. Okay. Is this clear? Any questions? Anywhere are you stuck? So when you open the SSH, it should show login as, which means it should be able to connect from your laptop. Okay. If you are stuck anywhere, please feel free to let me know so that I can come and help out. Okay, 1 second. So your topology is going to look something like this. Okay, so you will have actually three types of networks, right? So you will have a 192.168.50 network, which is the lowermost in the line. You could see that 192.168.50.0/24 in the lowermost line. Okay, that is going to be your management network. Then you will have 192.168.254.0. That is going to be your data network, right? And then you have 192.168.56.0 on the top. That is going to be your public network. If you remember the slides we went through before the break, we told clearly a cloud will have multiple types of networks, right? We talked about management network, we talked about data network, and we talked about public network, right? Management network is used to control the elements in a cloud. Data network is used for elements themselves to pass data among themselves. Public network is used for the elements or the workloads in the cloud to access the internet, right? So I am just telling you what is my management network, what is my data network, and what is my public network. So I want you to configure the management network now. So in order to do that, first you have to actually go to second. So you have to go here, you have to select file preferences, again select networks, in that select host only network. If nothing is there, create a VirtualBox host only Ethernet adapter. If you already have one, you have to edit it to make it 50.1, 255.255.280, give a DHCP IP and then say OK. Okay, and then I also told you to actually go to settings of each of this and make sure that the fourth adapter does not use para virtualized IO. Instead, you should change this to use Intel Pro network adapter and say OK. You have to do this for first two nodes. Yes. Yes. Okay. Okay. 1 second. Yeah, so basically here, I should select this one. Okay. So basically whatever adapter you are choosing in the preferences and you are giving the IP, you have to select that here because this is the one that will be using that IP. Okay. So similarly I should do the same. Thanks for educating me. I did not notice that it changed. So let me tell you why it changed. What will happen is when you go to file preferences to host only networks, whichever is the first network there, that will be by default chosen when you import the appliances, and that's why it happened. Now we changed it to whatever is the one that we are supposed to use. Okay, so please do the same in your setups. If you have any problems in between, please let us know so that we can come and help in. After you are done, please start your workloads. I mean, like, let's first start the control node. 192.168.50.100. I mean, that's the server you can give, and you can give a range from 101 to 254 or something. I mean, basically that doesn't matter because we have actually configured static IPs in the appliances, so it'll already come. Like, that setting is actually not required, but just for completeness sake, you know, when you want to do it yourself and you want to take advantage of DHCP provided by VirtualBox, I'll recommend you to configure this. So each of these nodes are CentOS nodes, and the first node, as you could see, is ODL 31 control Mitaka. That's actually a combined control node that runs my OpenStack controller, that runs my ODL controller. Okay. The second node, which is ODL 32 compute Mitaka, is a compute only node. So it runs my OVS data path, which will be controlled by my OpenDaylight controller on the other node, and it also runs certain Nova hypervisor side services, which will enable Nova based VM spin-offs. So it has services installed on it that are OpenStack specific. Okay. If you are stuck somewhere, please feel free to call us. Yeah. Yes. Yeah, for the first two nodes you will need all of them actually. Like in the fourth one, I wanted you to select Intel in the advanced section. Actually, you can look at the slides here. Yeah, so you can look at the adapter 4 selected in the slide here. So I want you to have to change from para virtualized network to virtualized network here, and here you should select a virtual adapter that will be the communicating point from your laptop. Okay, so basically what I meant is 50.1 should be the IP that your laptop gets, so that you can SSH to these nodes via PuTTY or somewhere else, because managing them through console is going to be difficult in VirtualBox. So better to use PuTTY so that you can easily run the scripts and scroll down, scroll up, look through everything, right? So for that you need a VBox 0 IP. VBox 0 IP you should configure as 50.1, because in my OVS I have actually configured 50.31 and 50.32 as the management IPs for the first two nodes. Okay. So I just kickstarted one of the controllers. I got into the console. Actually, when you go and click inside the black box, there will be a dialog box that will open to say you want to capture keyboard, give capture. Okay, and tick check the box and say capture. From that point, if you want to get the mouse